I'm going to talk about a few different ways of doing this question. All of them will involve including this length, RP, which is 2.4. And so if I take an individual triangle, I can now work out the hypotenuse because I know I've got four of them here. 1, 2, 3, 4. So I can do 2.4 divided by 4, which gives 0.6. And actually, I've got four lots of 0.6 here. If I look at it here, then I've got three lots of 0.6. And that's going to give me 1.8. One way to very quickly get the answer from here is to spot that this is going to be, oh, sorry, there's one thing I didn't mention. Here we've got a right angle. Now that means that this angle here plus this angle here must equal 90 degrees. But this angle here is the same as this one, so this here is 90 degrees. And that is enough now. We've actually got a 3, 4, 5 triangle, a Pythagorean triple, which means the final answer for PQ is going to be 5 times this length, 0.6, and we're going to get 3. That's a really quick way of doing it. I'm not, I didn't actually spot to do that when I did it. If you don't spot to do that, then of course you can just use Pythagoras' theorem now. You have to realize that that is a right angle. So it will then be 2.4 squared plus 1.8 squared, square rooted. You can do the decimal multiplication and so on, and then add it, square root it. You're going to get the square root of 9. You're still going to get the square root of, you're still going to get 3 as the answer. Let me talk about one final way you could do it. It's still going to involve Pythagoras' theorem, but I don't think it involves needing to spot that this is a right angle. This is actually how I did it. I'm not saying it's the best method, but it's what I did. So I've got my triangle and I'm going to call this side X. And if I look along here, I see that actually there's four of them here. This height is 4x. Now if I call this Y, then the height is also 3y. So I can see that 3y is equal to 4x. And what I can do now, if I want to figure out the length, if I want to figure out the sides of the smaller triangle, is kind of use Pythagoras on this. So I'm going to get x squared plus y squared is equal to 0.6 squared. I've applied Pythagoras' theorem this time on the smaller triangle. Because if I can work out x and y, I can just add them together appropriately to get to the length PQ. Now, what should I go with? I need to. This is actually what I've got is a simultaneous equations involving a quadratic because we have a linear function over here and a quadratic function over here. So I'm going to make x the subject. X is equal to 3 over 4y. And that means x squared is this all squared, which is 9 over 16 y squared. And I can substitute that in. I can replace this by 9 over 16 y squared. If I do that, I'm just going to get y squared here, but I could put it over a common denominator and write it as 16 over 16 y squared, and that is equal to 0.6 squared. I could write it as 3 over 5 all squared. Okay, if I keep it all as fractions, so then I'm going to get 25 over 16 y squared is equal to 9 over 25. Therefore, y squared is going to be 9 over 25. I can divide by 25 over 16 or equivalently times by 16 over 25. And actually, rather than working that out, it's best to then just take the square root. And the square root is going to be this square rooted times by this square rooted, which will give me 3 over 5 times 4 over 5, or 12 over 25. Yeah, this root is more complicated, no doubt about it. I could write that as 48 over 100. So I've got 0.48. I guess I could leave it as a fraction instead. That was y. Remember, x was 3/4 of that. So x, a quarter of it is going to be 0.12 times by 3, it's going to be 0.36. So just finally, I can then, add them up accordingly. So I've got 4y plus 3x. I think it was PQ, wasn't it? So it's going to be 4 lots of 0.48. I can double it to 0.96 and double it again to 1.92 plus 3 lots of this. That's going to be 1.08. And if I add them up, I'll get 3. Okay, it might have been easier to actually leave it in terms of fractions and add it, but either way, look, we can get the answer. So 3 methods of just different approaches. At the end of the day, we get that PQ is 3 centimeters.